French technology. So, I'm Frédéric Bisson. I'm a French developer. I work for the city of Rouen. But this project is on my pastime. It began when my employer started to give away its old French little boxes. So, yes, I will. Some of what I will say will be very ironic. First, we will see how France conquered the world. Next, we will see how it worked and how HTML5 and ES6 can be used to emulate a Minitel in a browser, in a modern web browser. And then you will have two live demos. One which will be creating a video text page, and the second we will be surfing on Minitel. So the French technology conquered the world, but in the late 60s we were quite a bit late. In the USA, 90% of the household had a phone line. In France, it was only 15%. In USA, at the same time, you would need 3 days to have a phone line at home. In France, it was 3 years. And I'm not joking, really, 3 years. The last operator worked until 1978. I was born in 1974. My parents had known this. But the first automatic switch was tested in 1912, 66 years before. It employed up to 30,000 operators, which makes every call super expensive. And but France has a super plan to take all over the world. In the late 60s, the government made a decision, and in 1972, the telecommunication became the first investor in France. In 1978, less than 10 years after, the PSTN was complete. The PSTN is the Public Switch Telephone Network. It's an automated telephone network. And at the same time, Transpac was born. Transpac is the French packet switch network based on X25, which is a technology so much better than TCP/IP. You know it. So Transpac worked from 50 bits per second, yes, because of telex, to up to 64,000 bits per second. It was heterogeneous because you could access it directly or via a modem or via telex. But its very innovative point was the billing, the pricing, because before you paid against the distance. With Transpac, you paid on rate and connection time. At that time, you could do B2B applications, like linking agencies for banks, insurance, connecting ATM machine, and have payment terminal. For the B2C applications, it was the Minitel. Minitel it's a video text screen with a keyboard connected to the network with an internal modem. So you have all this in this machine. But the main task was to get it adopted by the French, because if in USA the microcomputing was very present, in France it was a desert. Because microcomputing is hard to grasp, it was also expensive, and networks, nobody dreams of them. So the great French mind knew what to do. The Minitel was a plug-and-play terminal with zero configuration, zero maintenance. But you could not update it. There was one killer app, the electronic telephone directory, and which was free. And also the Minitel was free, like in free beer. So you just have to sign a paper and you could get your Minitel at home. But it means that the French government entirely paid all the Minitels. A Minitel costs 260 euros to build. It's 260 euros today. It was 1,000 francs in 1980. On this map, you have 750 million euros of Minitel. In 1993, there were 6.5 million of Minitel. So the French government needed to get the money back. But how it worked? The Minitel network, at home, you had a Minitel and a phone. The phone was used to dial the number because the modem inside the Minitel was very basic. The France Telecom network was an analog network on which was connected the video text access point, or PAVI in French. On this machine, you had the electronic telephone directory. You also had all the billing, and it connected the analog network and the digital network. The service provider had its servers connected to Transpac, but it could also have servers connected directly to the PSTN, but with the constraint that you would have less lines available. The Minitel, it's a Minitel 2. It's a little cube. It was a black and white passive terminal which communicates in 7 bits video text. Screens are composed of 40 columns for 25 rows, which gives us 320 by 250 pixels. It could display 8 colors, though nearly all the Minitel were black and white. And it communicates at, it downloads at 1,200 bits per second and uploads at 75 bits per second. Because 75, it's only for the keyboard. 75 gives you approximately 7 characters per second.
Typing that on this keyboard was...
This keyboard is quite good. To overcome the limitation of text screens, because it's a terminal, a text screen, video text has 64 special characters, the mosaic character, which divides each character in 2 by 3 pixels. So graphically, you would have 80 pixels by 72 pixels. And the graphist would have to use standard characters, like here, where you have an @sign to represent a button. Here, you have an anti-slash with a double width, the dimension, and a slash in its normal size. You have also a very complex set of attributes because each character is coded as 16 bits in the Minitel memory. But with this, you could encode 449 characters. So you have all that is necessary to have accented characters. You have RGB for the foreground, RGB for the background. You have blinking attributes. Here you say if you want to have alphabetic characters or mosaic character. You can say that you have underline, etc. You also have a video inversion. So what the video text stream looks like, to display FOSDEM 20, you would first start with 0C, which clear screens, and which puts the cursor on the upper left area. 1F for C4C, you go to row 12, column 12. 1B for F, you set double width and double 8. 1B43, you set foreground color to yellow. 46, etc. It's only ASCII characters to write FOSDEM. 1B4E, 1B46, 0B. So to have this screen, you need approximately 20-25 characters. The Minitel inside, it's like a small computer. The processor is a microcontroller, an 8032. You have all the program in an EEPROM, a chipset for the modem, a speaker, a connector to the screen, the video controller, and the RAM, which was directly connected to the video controller. The difference between web before HTML5 and Minitel, the web, the client initiates the request. The server cannot initiate the request. While with Minitel, the server and the client can communicate at any time. In the web, you have no state, while the Minitel is a continuous stream. You have a separation of content and presentation with HTML, while the Minitel is only a sequence of either a character or control code. The main feature of the web is its hyperlink system, while there is absolutely nothing like that with the Minitel. HTML is also hardware agnostics, while the Minitel is completely tied to hardware. And for the web, you have HTML, CSS, JavaScript, but you have only video text for the Minitel. What's needed to emulate a Minitel? A widely available platform with some specific capabilities. It must be able to do asynchronous communication, to have graphic primitive, and it is divided into 3 parts: the video interpreter, the video controller, and a Minitel service to connect to. So happily, with HTML5 and ES6, all we need is there. Because we can draw the Minitel screen with canvas. We can do keyboard click with audio. And the main capability is the WebSocket, which can do full duplex communication. And also ES6 brings lots of programming facilities, like promises, like functional approach, etc. So in fact, once you have that, it's very simple to represent a screen. A screen is made of cells, which can be either character, mosaic character, or delimiter. The delimiter is the space. The video display unit, written in JavaScript, reads the video memory 50 times per second. It will draw modified rows and also blinking characters. It will draw this with the foreground and background color, with video inversion, with underline, with size, with mask. But when you start underline, it will be taken into account just after the character. But when you use other attributes, it will be taken account immediately. So there are very, very small problems that can arise with this technology. So I will be showing you the Minitel page editor. It's available online. So, first, we clear the screen. We write content. Oh. If you want to have double size character, you can move the double size. And here you have the first problem with the Minitel. You cannot double size the first line. So you have to go through move. The second line. Up. And also every absolute move resets all attributes. So you have to put the sequence in the right order. You can blink. The marquee was made by the server. You can do video inversion, etc. You can also draw something.
If you can go back a few years in time, you could sell that for $500 million.
You must be aware that I have a mouse, but in 1980 and 1990, it was entirely made at keyboard.
How many colors can we display at the same time? On the palette?
So on a single cell, you can only have 2 colors.
Yes.
Okay, but I can feel the screen with all the colors. I can pixel art.
Sorry.
Can you repeat the question for the recording?
So your question was how you can have all these colors?
Yeah, how many colors on the screen at the same time?
How many colors on the screen at the same time? 8.
All.
And it's also the complete palette. It's because it's encoded in 3-bit, red, green, and blue. So you have black, red, green, blue, cyan, magenta, yellow, and white.
But like for the ZX Spectrum or other machines at the same time, within a cell, you can have only 2 colors.
Yes. Because though you see pixels, in fact, they are characters.
Artifacts combination.
Yes.
Two of your cells are cheating actually over there. Because I see 3 colors in one cell.
No.
Yellow, white, and background.
No. It's on. You have here apparently many more than 2 colors in a cell. It's only because you are in an editor. If you save graphics, so you can draw the thing at the Minitel speed. You can also record your animation in a GIF format. The GIF encoder was entirely made in JavaScript.
Why did you change the color?
Maybe it's a bug. So, this is for the editor.
I'm sorry, can you explain what is the C on the top right? Repeat the question first.
What is the letter on the top right? The letter on the top right indicated the state of the connection.
Yeah, connected.
Yes.
And so this is sent by the server, actually.
No. The editor works entirely locally.
No, in the real Minitel.
Yes. I will show you with the next demo. Because here's the killer app of the Minitel. So, for example, if I type my name, I will do suite is next. So you go to the next field. Next. And envoi is send. For this, you have to thank Christian Quest because I did the front and he did the server.
So it's a real. These are real.
Yes, they are real numbers.
Okay.
Because the server Christian Quest made online just queries the 118, 712. Yes.
So that's why they have 10 digits.
Yes.
Don't
But
have GDPR in Spain, even in France.
these are data.
Or it's on French, but nobody understands.
No.
Just his family, so they're all consenting.
When you use the Minitel, you would do a 3615. This is the kiosk, and you would type the name of the service. For example, so this is only the logging screen. Behind it, you have a Mastodon instance.
Okay.
Hop. It's okay. So, on the emulator, you can set the speed. So, it's Teaser was a service you could access either by the kiosk or by the standard numbers. So depending on your Minitel, you would use one of these numbers.
The kiosk was like a Google Analytics, basically.
Sorry.
Like a special site in which I can search for the stuff. Where is the kiosk?
No, the kiosk you had to keep the exact name.
Yes.
It was not. So
Sorry.
It was not like a search engine.
Okay, but it's not built to go there in a place where I go.
It's you go there.
Yes.
And it's basically it was more like Yahoo at the time where you had a catalog of things. that you could-
Whoa.
And the items were selected by typing the characters. So, for example, for the museum, you would type star MUS. You could use code to make special effects. Etc. Yes. You also have love story.
You can decide to go.
Do you have any question? The hacker demo. I don't know. It's only a forum. Yahoo.